character. Whereas with binary, it would just take 1 byte, the value hexadecimal C7. I know this is review, but it's important. So 3 bytes versus 1 byte. It's the same information, though, but the way it's represented is very, very different. So there it is in binary 199, and there's character 1, character 9, character 9. All right. So we have these different classes that we're working with. We're not going to work with all of them directly. We've already seen file input stream and file output stream, and we've seen data input stream and data output stream. And those are the ones that we generally use for primitive binary file I/O. The input stream has read methods. Read will read a byte. So it's going to read the next byte of data from the input stream. The value byte is returned as an int value in the range from 0 to 255.
Is that to represent like ASCII?
Not necessarily ASCII. ASCII is a small subset of that.
Including the control characters?
Yes. So this is all any value between 0 and 255. So any byte value. If we've reached the end of the stream, no byte is available, then -1 is returned. So this is why read is returning an int and not a byte. Because byte in Java, what's the range of values that we have available to us for that primitive?
Isn't it -128 to 127?
Yes, -128 through +127. So if we are reading this in as a byte, we'd have no way to differentiate between, is this a valid byte or have we reached the end of the stream? Whereas with an int, because that is 32 bits, -1 is not the same as 0 to 255. So because it's using an int, it's just going to use the least significant bytes, or the least significant byte, I should say, for the value. And then the most significant byte would give us the, if we're getting -1, that means then it's not a valid byte. We've reached the end of the stream. Does that make sense?
Yes.
Okay. You can also read a byte array. And the way this works is you would pass the byte array into the read method, and the array gets populated, because remember, arrays are objects, and being objects, what we're passing into it is a reference to that array. So the array would get populated with the values, and then if it reaches the end of the stream, this would return -1. If it doesn't reach the end of the stream, that is, if it actually read in values, it's going to indicate the number of values that were read by this. We can set an offset and a length for this. So if we want to start at a specific position in the stream, we can do that skipping over bytes. We can check to see if another byte is available, or the number of bytes that can be read from the stream.
It was read byte with an off.
Okay, so that would give us, starting with, so it's going to read bytes from the input stream and store into So it's an offset for the array. So if we're building on an array, for instance, and we want those bytes to go into a specific part of that array, would start at that position, go up to the length of whatever's specified by length.
So basically that method is just for organizing sakes.
Yeah. Whereas, okay, so this method here, read just byte array, that would be the equivalent of read b value 0 and then length of the array. If that makes sense.
Yeah, I think that makes sense.
Close. Again, input streams, not as important to close as output streams, but good habit. Skip, if you want to skip over bytes in the stream for whatever reason, you can do that too. Mark and reset methods on the input stream. I don't think we're going to go into that, but it allows you to actually mark certain positions in the stream so that you can actually jump around this. So it will reposition the stream to the last marked position. So a little bit of control. It's not just starting at the beginning, going to the end, although that's usually how the streams are used. We're most likely not going to get to those bottom three, primarily because there's a much better way of doing this. And we'll talk about that either today or Friday. All right, output stream. And just worth mentioning, input stream, very, very different from scanner. It's much lower level than scanner. So keep that in mind too. Output stream. Write, again, very different from print writer. So we're writing a specified byte to the stream. Parameter b is an int value, and the value is cast to be a byte. And that is written to the output stream. You can also write an array of bytes. You can also use the offset in the same way. Closing the stream, also important. But we also have a flush method. So if we don't want to yet close the stream, but we want to be sure that whatever's in the buffer has been sent to be written out, we could call flush. So to read from or write to binary files, we're going to create file input stream and file output stream objects. This will associate those input or output streams with the external file. We're not going to work with those objects directly, though. So a way you could use file output stream or file input stream, you can pass to it a file object, or you can pass to it a file name. I think this is the preferred method, honestly. You can also, for output, specify that you want to append to the end of the file, as opposed to just overwrite the file.
What does append mean again?
yet you are adding to the end of it instead of overriding it.
Okay, thank you.
So if the second argument's true, then it's append instead of overwrite. We're not going to talk about filter streams beyond data input stream and data output stream. So data input stream and data output stream, you'd want to pass the file input stream and file output stream to those constructors. And we saw examples of that. So you create a new data input stream, you pass to that the file input stream. That gives you the input stream that allows you to read and write using the data types. So you can read booleans, bytes, chars, floats, doubles, ints, longs, shorts, lines. So we can still have strings of characters inside of our binary file. You can also read strings in UTF format.
Professor Warren, why would you use this? Like, why would you read from a file instead of using like the scanner or like the buffered reader? Is there a scenario in which you would use this over the scanner?
So this is how we would read from binary files. Scanner will work for text files. It will not work for binary files.
Okay, thank you.
The other thing to note, and this will probably trip you up, so just be careful about it. Notice that data input stream has read boolean, read byte, read int, etc. With scanner, it would be next boolean or next byte or next int, etc. So just be careful about that. If you're using an IDE, you'll catch that pretty easily. Other questions?
What we have to watch out for again, like with the boolean?
So for scanner, for text file input, the methods are called next boolean, next byte, next int, and so on. For data input stream, so for binary file input, the methods are called read boolean and byte and int and so on. So just being sure you're using the right methods for what you're doing. Other questions? All right. So data output stream, write, boolean, byte, bytes, chars, float, double, int, long, short, and UTF. And again, to create the data output stream, so for writing to a binary file, you'd create a new data output stream and you'd pass to that constructor a file output stream. Which I know this is incredibly verbose when you go to write this code, but that's how you do it.
So all the objects ending in stream are really only used for binary files, correct?
Yeah. I mean, you could use this for text files. There's no reason you can't. It's just, there's also no reason you would.
Okay.
Does one way work better than the other?
They'll both work. It's just, if you're using this for text, you'd have to be sure that what you were writing to the file is just chars, strings.
Okay.
Whereas if you're using, say, print writer, and you do print ln, and you pass to that numeric values or other things. Well, if you pass to it a numeric value, it's going to convert that to characters. It's going to write it as text. Whereas if you pass a numeric value to this, it's going to write it as the data type it actually is. So if it's an int, it'll be 3 bytes and it'll be represented in binary. All that makes sense?
Okay, one more time.
So if we are writing to a binary file using something like data output stream and write int, it's going to write in binary. So it's going to take 3 bytes. It's going to write those in the binary encoding for that int value. Whereas if I'm writing an int using print writer to a text file, it's going to take however many digits it takes to represent that value, and it's going to write it in plain text.
Okay, that makes more sense. Thank you.
So characters and strings in binary I/O. So Unicode is a coding scheme that consists of 2 bytes. Yeah, this is not the whole picture. UTF-8 is a coding scheme that allows systems to operate with both ASCII and Unicode efficiently. That one's used often. This is the sort of thing where I would recommend actually doing a little bit of research online. I will probably do this myself and find some good links for you, but it doesn't hurt to look up how is Unicode actually represented. Here we go. So actually, this part here is the UTF-8 is an alternative scheme that stores a character using 1, 2, or 3 bytes. ASCII values which are less than 7F are coded using 1 byte, and Unicode values less than 7FF are coded using 2 bytes. And to see the details of all of that, it's a little bit messy and tricky, but it's also kind of interesting because this is how they expanded the character set of printable characters without having to use, say, a fixed length of bytes for each character.
It says most operating systems use ASCII, and then it says Java uses Unicode. Do they mean to say most programming languages, or is that correct?
That's actually correct. Most operating systems do use ASCII, and Java uses Unicode.
Okay.
So low-level stuff, mostly ASCII. Unicode was developed to make applications, especially web-based applications, more universally accessible and available across languages that don't use the Latin alphabet. Operating systems have since incorporated that into what they do, but a lot of times still working with the shell or still working with the command prompt. Sometimes you'll run into, it's a very limited character set. Sometimes it is localized to different nations, but oftentimes, if it was a computer made in the US or made in the EU, then it's Latin alphabet and restricted to the Latin alphabet. It's gotten better over the years. but that was definitely a limitation for many years in many operating systems.
Professor Armin, can you when I haven't really when are binary files really used, like in a project sense?
All right, so think of it this way. Let's say game development. I could create save files using plain text. Why might that be an issue, though?
I guess.
Two reasons.
I guess people could find them and edit them and break the game.
Yes, that's one reason. The other reason is reading data from a text file is not machine efficient. It's human efficient. So it would be better if that data is binary encoded, because it will make the save files smaller and it'll be read faster by the program application or whatever. But the other thing is, anything on the computer that is not a text file is a binary file. That includes images, audio files, video files, all of that data that cannot be neatly represented as text. So any sort of multimedia work that we're doing needs to be able to read and write binary data. And if for whatever reason we wanted to work with that data at a low level, so if we say wanted to develop our own video codec or our own audio codec, then we'd have to work with binary in this way. Databases, because they hold such large amounts of data, even though that data needs to be translated into plain text so that when it's read by authorized users, it's meaningful, but it typically gets compressed somehow in some binary form.
Wait, what is that?
This is what I call mutant skelly.
So there's lots of pretty much anything that doesn't make sense to do text would be binary.
Mutant gang. Mutant gang. Carl, pick. I'm on zombies, I guess. Server, drop the glass. Let's see who is correct.
Another thing is
What are you doing?
all of the programs that we compile and run. Java bytecode, executables written in C or C++. Those are, of course, binary because the computer needs to interpret them and execute them, and it has to be machine code. But we might also need to debug them or reverse engineer them. So decompilers, disassemblers also need to be able to interpret or read the bytes from those binary files and try to translate them into the corresponding assembly language.
Bees are beating a wither server spawning in. Let's go bees.
So that's
Wait, what?
just a few
They're
things.
so adorable. Oh, he hit one bee. I'm starting to change my mind. Why did I pick the wither?
Look, these bees aren't even mad yet.
So they don't all get wiped out by
So
Bees
already
are
kind of
smart.
went over
Bees
this.
are smart.
Data
Wither,
input stream,
who died of
data
bees?
output stream.
Do something.
Oh, the health bar hasn't moved though. And while we're
Those
watching
are
this wither
used as
mercilessly
wrappers for
slaughter bees, I want you
existing
guys to
input
play
and
along
output
as well.
streams.
Here we go.
So typically,
Bees, okay?
Oh, he's in the corner.
something
The bees
like
are doing
what you have
damage.
down
Turn
here.
around, you idiot.
Data input stream.
Oh,
In
all the
file.
bees are on the wrong side.
I will
Oh my
typically call this
God, go
fin,
bees, go!
file
The cat
input.
loves that couch.
So-
I can't lose it.
But whatever, as long as you're consistent. Doesn't matter what you call these objects.
Stream it live.
So
on
data
NBC,
input stream in file
YouTube
equals
TV.
new data input stream, new file input stream, and you can give a file name, file path, or file object there.
Speed mode! Oh my God, he's
Same thing with data
These are
output
the
stream,
last four
out
Bs.
file,
Alright, I
new
got the
data output
child.
stream,
I will
new
feed
file
him the
output
child.
stream,
No.
file
no,
name,
he does-
file path, or file option.
Oh, the child! And with that, the Wither won. Me and Chandler just got
If
a
I
point,
click
which
on
means
test
Chris
data
is
stream,
the
you can see an
only person
example
not
of
to
this.
score so far. Up next is 20 mutant zombies
me
versus
zoom in.
20 mutant Endermen.
I'm going Enderman.
Zombie!
I'm going with
So,
Enderman.
creating
look at
a
those
file
Endermen.
called
It's gotta be Enderman.
It's
Did I
temp.dat,
pick the wrong one?
Look at them.
writing
they
a
doing? The zombies are
Unicode
so
string
confused.
name,
Holy, you
writing
just
a
lost that
double,
dude.
He's just chilling,
and just
taking
doing
a nap on the
pairs of
battlefield.
names and
Please,
doubles.
Enderman, this is for
So,
my couch.
Isn't
student
it funny
test
to
scores
think
here.
that these mutant Endermen have the fate of our couches in their hands, as well as giant
That
stone
will
blocks, apparently.
Belly
write
flop.
that
Come on,
data
come on, get out.
to the
I'm gonna
output.
get close to them and listen
There
to their
is
screeches.
missing a
This will haunt you.
It's looking like the Endermen
output dot
Oh,
close.
oh,
You
Oh,
need
it happened
that.
so quick.
Shame on the textbook writer for excluding that.
Poor guy. And we got the dog.
My couch is.
What happens when you don't do that?
You might end
Everyone
up
has 2
with
points except Chris.
Sadness.
an empty
This
file.
next one is actually a
But
brain
all that
teaser.
said,
One wither,
there
or
is also
500
something
skeleton.
kind of
Take your
special
pick.
going on here that I didn't talk about, and that
I'm
is
gonna pick
a
Wither.
try
I'm
with
actually picking a
resources.
skeleton.
Wither, screw it.
So,
Oh, wait, no. It's
because of the way
definitely
this
You're
is
going
set up,
against your own
this
logic
might
that
still
you
work.
had that one time.
because it regens when it does damage. Darn it.
The bees had a better chance.
this
You
is
didn't
not
see how
generally
dumb
what
the
I'm used to.
skeletons were
This
when
would
they
be worth
faced the
testing at
zombies?
least.
They're just owning them.
The skeletons are killing themselves, nerds!
They literally are.
The Wither hasn't done a single damage yet.
Just
You
don't
can
vote
also
for
test this and run it
Skeletons are
Kel-
dumb.
on the
skeletons are
machine,
literally
and
just
it actually
stupidest
looks
thing
like
in
it
Minecraft.
works.
Chandler and Carl are tied for first with 3. Me and Chris
There's
are tied
waits-
for last.
There's a
the,
chance for my couch.
website
I'm
lets
doing
you
this for
test it in the
baby.
My
browser.
couch is now in jeopardy. 100 Blaze versus 500 Snowmen. All right.
So
pick
I
a
encourage
side.
you to
Snowman.
look at these examples and play
I'm Team
with them.
Blaze. Wait, all 3
Um,
of you
So
went
the
Snowmen?
the read ETF
Drop
for the from
names,
at the
let's
end
have
for
it.
system that out
Oh my
that
God.
print.
Oh, snowmen are getting hit.
That means it
We
reads
messed up bad.
every
This
ETF
play is
until it
so
reaches into
melting.
a different
It's like a
type, like a
freaking
double
Warzone
or
game.
a
Wait, we might
boolean.
lose.
Yeah, I
Correct.
think I might
So for a string,
Go.
there is a special character that represents the end of the string.
Go.
That's what it sounds like.
Wouldn't that be
Ray,
the
between
enter
windmill
character?
and snowballs.
Oh, we are gonna win.
That would be a new line character, which is not necessarily the end of the string.
What the
Actually, that might be what's being used here.
Frosty the snowman just saved my couch.
Fire
That would be
snow.
worth
No
looking
kill
into.
Fire.
Yeah.
Up next is a really hard one.
But
1,000
since
zombies
read
or
UTF,
the Iron Golems.
you're getting the
Golems.
Alright, I'm going zombies. This is the time I'm smarter than
name,
them.
but you're not
let's
giving a
go.
new
Start
line.
chucking them
That's
babies out.
probably
They're
not
getting
what's being
gold,
used.
Chris.
They're taking a lot of damage quick.
They're getting a goal.
They're hurting each other. They're hurting each other.
There's a way we could actually check.
Smart! Go! Yeah! That a boy! I don't want to
Let
lose
me
my couch!
Wait, look, it's
Copy
actually
this.
I think I got the dove! Get out of here!
I hate you all.
I'm no longer in last place.
I'm going
I
to
am now
recreate this
tied for
here.
Last place. I honestly have no idea what the answer to this next one is. 10 giants or 1,000 skeletons.
So,
Mine's like skeletons, right? But they're stupid. Oh my god.
I didn't mean to go to the side.
Come on, giant, baby.
Wait, so are all Team Giant?
I'm from New York, okay? I gotta be a Giants guy.
The Giants are just decoys. Oh,
To
they don't even
new
attack.
file.
I was on the skeleton side.
No.
Test data
But wait,
stream.
will the skeletons just kill each other?
Gotcha.
Oh god. What the heck?
Oh.
1 mutant creeper or 1,000 zombies. Take your sides.
It's about the explosive damage, because if it blows itself up, it's all over.
I'm going with zombies, dibs.
I don't know what a mutant creeper is.
I'm going zombies.
I'm going zombies.
I'm gonna go zombies.
Some weirdness going on there because
He's about to explode.
Actually,
About to explode.
Whoa.
missing
We
quote
all
there.
got it right, but we're lame. 100
Oh.
skeleton horsemen or 1,000 zombies.
1,000 zombies.
Yeah, this is
1,000
testing you.
zombies.
So
I'm picking horsemen. Chandler, me and you got this.
Yes, Chris, we got this.
let's fill in the code
I
here.
thought skeleton horsemen would have like.
New data input stream, new
Oh,
file
you're
input
done
stream.
for.
We don't got this. We don't got this, Chris.
What was that?
Temp.dat.
Blessing your couches right now?
Yes, that's a kind of.
Dude, this slideshow is amazing.
Wait, are we gonna win? We actually might win this? Chris, we're gonna win. Chris, look at me.
All
in the
that
eyes.
looks
I would
good.
be
Let's
looking
run
at you
this.
while we win. I don't even need to see it. I know we're gonna win.
Oh my god, turn around, last one. He's dead.
We won!
We did it!
So, I am now in dead last again.
Hey, RIP your couch, buddy.
50 snow golem or 1,000 zombies.
Zombies!
And sure enough,
I'm
that
going with zombies.
worked.
Oh, wait,
That
wait,
read,
wait,
and
wait,
it created that temp.dat file.
Dear God! Oh, the
Let me take a look at that.
My headset, I was
Well,
so
it's a
excited.
binary
I didn't know we
file,
were talking
so
about this kind
how
of
do you
cell
suppose I'm
phone.
going to take a look at that?
You're gonna use a converter?
I'm going to use
Always
actually a
trust
hex
in the
editor.
Zombies.
Zombies are OP.
Chandler, we won.
What about me? I also won.
So
We don't
this
stop winning. Yeah. we
will allow
can't
me to
lose.
look
All right, me and Chris
at
are tied
each
for last
byte
place.
in that file.
Who's gonna lose our couch?
One
500
byte at
llamas
the
or
time.
500 zombies.
Llamas.
Llamas.
I will give up my couch.
And
to
what you'll
llamas.
see here
I trust my llamas.
is
Go zombies.
Yeah, I'm
we've
gonna go
got
zombies.
some
Why do llamas look like that? It's a coffee cup.
preliminary
Oh my God!
stuff.
Oh my God! What are they doing?
Are they spitting
Let
on the
me,
zombies?
The power of spit.
Even if we lose, it's
move
worth
this
it. I
aside
love
here.
my llamas.
So intertwined.
Oh my gosh, it kind of looks like.
So we've got
country music now.
0004,
Oh yeah, it does.
Whoa!
Whoa! I'm
and then
not
we've got
seeing as much
4A,
green.
Oh my God.
6F,
Oh my God.
6
Yo, they're
8,
going off
6
now.
E, and that's
Llamas,
JOHN.
llamas.
Llamas!
And then we've got 40.
Llamas!
I'm in dead last. I am now in last place, and Chandler and Chris.
The
are
space
tied for
character,
second to
right?
last.
Yeah, let's go.
Up next is 500
That is not a space.
pillagers versus 500 zombies.
Pillagers.
Fine,
Actually,
I'll go
it
zombies
looks
because
like
I'm not a sheep.
They're
that's an
skeletons,
ampersand.
but smarter.
Oh, the zombies are dying.
That's right. That's what happens when you're not a sheep.
Okay.
I'm not a sheep. I'm just dumb.
You're too far ahead. Leave.
Okay.
which
The
is kind
three
of
us
interesting.
Are tied for last place with
Going
one
to
more challenge left.
here.
Hey, we're all losers together.
Pick
5,
your
3.
side before you even know what it is.
Yeah.
Oops.
Oh, no.
7
You
5,
guys
7
paired
3,
against
6
me.
1,
100
6
mutant
3,
zombies
6
and 100
E,
mutant skeletons.
4 0.
Oh no!
We got the zombies. Let's go.
Alright, I'll see you guys later. I'm gonna go figure out what to tell my wife about the couch.
All right, drop the glass. Let's see what happens.
So
No.
Whoa!
Holy. Whoa.
They're
Java
coming from the sky!
Look at this. Look,
has
they bounce
some
up and
sort
they just
of
shoot from the air. That's
mechanism
hilarious.
for
Oh, you
indicating
dropped my man!
that
You dropped him!
It looks like
that's the end. As a matter of fact, something else to notice
the
here.
Skeletons are winning.
By a lot.
Yes! I don't gotta get rid of
There's
my
something
couch.
really interesting going on here.
They deleted it!
0004,
which means now me
followed
and
by
Chandler are tied for
JOHN.
last place.
Let's go.
Going to
Chris.
Susan.
Let's go.
It is now me.
0005, followed by
We don't know what's gonna spawn on each
SUSAN.
side. Are you picking that side?
I guess so.
Going to
There you go.
Kim.
Because I wanted this side.
0003, followed by
1,000
KIM.
zombies versus
What do you
2
suppose
mutant
those
creepers.
Yo.
first number is
Whoa.
before the name?
Okay, I lost.
Taylor,
Maybe
RIP
the
your
memory
couch.
location?
Taylor, looks like you're about to
Not
lose your
memory
couch.
location.
And I don't see any zombies.
I'm so hurt right
The
now.
length of
Four.
the string. The length of the.
5,
Because,
yeah,
random
3.
subscribers
Length
hitting
of the
it.
string.
So I lost
So there is a number before the string saying how long the string is, and there's a number, and there's a symbol after the string saying this is the end of the string.
What's the ZP? Like, why hasn't that been used then?
Why isn't what used?
The ZP right after the ampersand.
That represents something else. 5A, 50. Well, what's the thing that was stored after the name?
We wondered if 6 seconds was long enough to make you crave fries for the rest of the day.
A number.
Oh, it's double.
Yeah. 5A, 50, 00, 00.
The world desperately needs.
So these are probably the double values somehow encoded as the numbers. Actually, this ampersand, that might be a coincidence, that might be part of the double value as well, since that number there is indicating how long the string is. So there's a little bit of magic going on there because we haven't looked at how data output stream and file output stream actually work. We know how to use it. We don't know what exactly they're doing beyond writing that information to the file. For some of these things, it's not that difficult to figure out. We could, if we wanted to, write individual bytes to the file, and then we'd have control over exactly what that file looks like. But with this, we'd have to actually look at what's going on there, how these things work. All right, back to the slides. All right. So reading from an external file, it's going to go through the file input stream, through the data input stream, and then we can extract the different Java data types from that. Similarly, writing to a file, it's going to go through the data output stream, through the file output stream, and then get written to the file as bytes. When you are reading from and writing to a file using these mechanisms, you need to make sure that you are reading things in the order that you wrote them. If, for example, I try to read double before I read int, that's going to break this. I'm going to get a whole bunch of gibberish. I need to read the string before I read the double, because I wrote the string before I wrote the double. A good practice is checking to see if you've reached the end of the file, which you could do input.available. If that returns a 0, that tells you you're at the end of the file. If you try to read past the end of the file, you'll get an EOF exception. All right. Buffered input stream, buffered output stream. All right, so those do not contain new methods. They're all inherited from input stream, output stream. However, it does allow us to use or to specify a buffer size. This is the sort of thing that we'd probably use for copying files. So if we want to copy a source to a target, we probably first check to see, does the source exist? Does the target exist? If the source does not exist, error. If the target already exists, error. Otherwise, copy. So what does this look like? So it's going to take 2 arguments, source file, target file. Source file is going to be arg0. Target file is going to be args1. Make sure source file exists. Make sure target file does not exist. You can also see for these, there's system.exit in different numbers. So conventionally, programs return a value when they exit. If they return 0, that means everything's great. If they return not 0, that means something went wrong. So
why do you have to use a different exit number?
System.exit, it's just a convention for saying something went wrong. So these could get associated with different errors.
Okay, I see.
So any program that's calling this program could then interpret based on the returning value what the error was. So I'm going to try to create a buffered input stream, try to create a buffered output stream. We are going to copy 1 byte at a time. So we need an int R for the byte that we're currently copying, and an int to keep track of the number of bytes copied. And while R equals input.read not equal -1. So as long as what we are reading is a value that's not -1, we're going to write that value to the file and increment the number of bytes copied. And then display the number of bytes copied. Very, very simple program that will allow you to make a copy of files, 1 byte at a time. Any questions? Take a look at these different examples, try them out, see what you can do with them. Just be, and we're working with files, so just be mindful of what files you're reading from and writing to, and make sure that you don't overwrite things that shouldn't be overridden. But it is very difficult to make a mistake of that level, so try them out. See what you can do.
You say that until it happens.
Yes. That is true.
Murphy's Law is full swing.
Mm-hmm. Any questions about any of this? So Friday we will likely have a quiz. It will be on file I/O in general, so you should understand the file class. You should understand scanner and print writer for text input and output, and you should understand, at the very least, data output stream and data input stream, file input stream and file output stream. Being able to recreate and use those are good things to know. Friday we'll also talk about object input stream and object output stream. And this is where Java's capabilities and power really come into play. Because being able to write objects directly to a file, read them directly from a file, without having to do any sort of conversion or thinking about what that object is kind of nice. So last call for questions.
Can that be like memory? And if you abuse that feature, you're going to end up using it too much and create more problems down the road?
It shouldn't. So it's worth saying that with any of this, it's always good to be mindful of, well, one, what you're trying to create, but also the target platform you're creating it for. So for things like desktops and servers, most applications we create, we don't have to think too terribly much about resource management. Memory has become cheap. Disk space has become cheap. It's only when things get really complicated or really time intensive or time critical, I should say, that you have to start thinking about those things again. Or in cases of if we are developing things for devices with limited resources. So mobile devices, embedded devices, then we have to think about, well, how can we more efficiently represent these constructs and persist these constructs on, say, a limited amount of memory. And I'm going to be real, a lot of mobile developers just don't get this right anymore because mobile capability has blown up too. But because they don't get this right anymore, you have things that are just not good.
Like
which is
Windows
unfortunate.
Mobile, Windows on
Yes.
ARM.
Yes, or say maybe 1 in 3 Android applications. Take your pick. Anyway, this is a good place to wrap up. We'll talk about Object File I/O on Monday. Stay safe and healthy. Not Monday, Friday. Today's Wednesday. We'll talk about Object File I/O on Friday. Stay safe and healthy, and I'll see you on Friday.
You too. Bye.